Good evening. This is a demonstration video to show my code. As you can see, there are 4 Python scripts over here. And first of all, we look at the KNN classification with fashion MIST dataset. First, we import some module like this and import the dataset. There are 10 categories over here. The reason why we divide 255 is a normalization method to change it from 0 to 255 to 0 to 1. And this is the shape of the train and the test. Then we reshape the train test and test to from 28 multiple 28 into 784, and then there's a loop to print different k with b equals 1, and the output is the accuracy is the same. The difference is the p here is 2. And we compare the results. We chose k equals 5 and p equals 1, which means Manhattan distance. And we train my model and output the prediction of the test. And then we get the confusion matrix from this code and get the precision recall and F1 score from this code. That's all for the first Python script. It is the same to do with the assignment1 dataset. The difference is there are 10 different categories over here, and the shape is different. It's 32 multiple 32 multiple 3 because it is a colorful image, but we change the RGB to grayscale, so there are 1 channel here. And it's the same with the fashion dataset. And the warning shows the shape is the column vector is very big, but it doesn't matter. And we compared all the results. And finally we choose k equals 9 and p equals 1. Is Manhattan distance true? After all, we get the confusion matrix and evaluation matrices true from the 2 code. Then we go to see the TensorFlow. The neural works based on TensorFlow. The method to import the dataset is the same. The difference between narrow networks And the KNN is over here. We create a narrow network. And we change many hyperparameters, like the numbers of neurons and the activation, the type of activation. And the model summary is here. We can see we have four layers. The first is the input layers and two dense layers, two dense layers and one output layer. The loss we choose the cross entropy loss function because MSE is not suitable for this. And the optimizer is ADAM. This is echoes. Over here, we can see that the change of accuracy. And this is our prediction. We can see it is the last, so we use this code to find the position of the biggest numbers in the row in every row, and we get 91 and something, and we compare the prediction results with the labels of test, so we can get the confusion matrix and the evaluation matrices. And cipher10 is over here. It's the same. Oh, we have to change here because the size is different between cipher10 and fashion MISG. And this is the model. Here we choose SGD because we found SGD is better than ADAM. And we also get the prediction results. And use this code, we can get the computer metrics and evaluation matrices. But the result is not good. As we can see, bird, deer, and frog, we cannot predict it precisely.